Fantastic. Thank you, everyone. Now, this afternoon, we're going to do something a little bit different. I'm going to tell you a story. And it's important that story is trauma-informed, so a brief content warning to start. This talk involves a real-world rail accident. There's no loss of life. The most serious injury is a dislocated knee. Let's get started. This talk is based on the Rail Investigation Report by the Australian Transport Safety Bureau. I have a copy here in case anyone would like some light reading. This is included in the opening pages of that report. Now, I am not a representative of the ATSB, and so the emphasis, explanation and analysis is for the dramatic effect of this talk and not the intended intent of the authors. Furthermore, and now perhaps rather obviously, we will be taking this report above and beyond its intended means so that we can learn some lessons in the software and technology space. So let's set the scene. It's shortly after 9 p.m. on Monday the 3rd of February 2003. It's a warm summer's evening, about 27 degrees Celsius. And importantly, there's a light northerly breeze. Before us is a busy Spencer Street station. Spencer Street was later renamed to Southern Cross a few years after this incident. All 7 of the country platforms are full of trailer cars and locomotives. There's very little spare trackage, and there are no empty platforms. On platform 2 specifically is an N-class diesel-electric locomotive, N463, and it's about to operate train 8141, a service to Bacchus Marsh. There are 4 trailer cars attached, and it will soon have a driver, guard, and passengers on board. The signallers are planning for imminent departures and have set the routes for 4 trains, including the overland service to Adelaide on platform 1 and our Bacchus Marsh service on platform 2. Do you have this scene set? We'll return back to here in a few short minutes. Almost 17 kilometres away to the north of Melbourne is a 3-car EMU, electric multiple unit. This EMU consists of motor car 393M, trailer car 1048T, and motor car 394M. In the image here, we have 2 3-car sets combined to make a 6-car set, and that's a fairly standard operating configuration. You see, these trains are designed to run in both directions along the line, and that allows for efficient turnarounds at terminating stations. That means they can be driven from 2 different cabs, one at each end of the train. With 393M leading the way, train number 5859 arrives gently, on schedule, into Broadmeadows Station. Broadmeadows is the last station on the electrified network, and since we're in the privatisation era of Melbourne's train network, this is where M-train services terminate. Melbourne locals will know that this line has since been extended and is now called the Craigieburn line. The driver said that he noticed the passenger information displays on the platform were showing the next train as being a Seymour service. This led him to think that he may have to perform a shunting movement to clear the platform after arrival. Based on this assumption, the driver isolated the controls and applied the brake. After a wait, he stepped onto the platform. Now, we assume that he intended to speak to the signaller to confirm this, given that the signal box is actually on the platform at Broadmeadows. Thankfully, though, by the time he'd stepped onto the platform, the passenger information displays had updated, showing the next service to the city, so there'd be no need for that assumed shunting movement. It's now time for our EMU to operate train number 5264, so the driver briefly cut in the cab once more and entered 5264 into the controls. This set the onboard passenger information displays so passengers could board. The driver cut out the cab one final time and proceeded towards the end of the train, where 394M would soon lead the way back to Spencer Street. This procedure is called changing ends, and it's a formal procedure documented across 3 different policy documents. Does anyone here have some standalone docs, a technical reference, a tutorial, an SDK off on the side? When was the last time that was reviewed for continuity, accuracy, or safety? Well, the ATSB report noted that the relevant documentation for our changing ends procedure had not been reviewed or updated in over 5 years. En route to cab 394M, our driver deviated to the bathrooms. In exactly 16 minutes and 33 seconds, train 5264 will crash into Spencer Street, and we will be following along in real time. When the driver set the onboard passenger displays for 5264, he was using a system known as POTS. POTS is Position of Train System, and it's a 2003 equivalent of a modern-day observability tool. In addition to retrieving information from a server and setting the onboard displays, it also tracks crude telemetry such as the pantograph position, the train speed, and importantly, whether or not the brake valve is open or closed. The speed of the train in this talk is calculated primarily using POTS data that was retrieved after the crash. The speed has also been adjusted based off explicit speculation from the investigation around its peak speeds between certain transponders. At some point while I've been explaining POTS to you, the previously stationary 5264 has started moving ever so slightly up and out of the platform. Movement will have been extremely subtle at first, as the train took almost 2 whole minutes to reach the end of the platform. The report is inconclusive as to the direct cause of the initial movement. Broadmeadows is on a 1 in 5,000 gradient, which means it's almost flat. But there is speculation that that light northerly breeze may have assisted. And so, assisted by gravity and wind, our train passed the up signal, and POTS recorded our first speed measurement of 3 kilometres per hour. Shortly afterwards, a passenger complained to the station manager, who then conferred with the signaller. They were all surprised to see 5264 some distance away, having departed early. It was now almost 3 minutes since the initial movement of the train that our driver reappears to the platform, refreshed after using the facilities. As one would, the driver spotted the train gently running away from the station, and he took chase, jumping onto the tracks and sprinting after 393M. The average 30 to 40-year-old can run about 4 to 5 kilometres per hour, but despite our driver's best efforts, he was unable to chase down the train. As 393M got smaller and smaller into the distance, the driver stopped chase and used the phone at the signal box to call back to Broadmeadows and convey the news. It's at this point, about 4 to 5 minutes after the train's first movement, that Metrol was alerted. They've got a runaway on their hands. Metrol is the operator of the rail network. They're responsible for train control and signalling. POTS is not specifically a real-time system on its own. The only way to track our train is to observe it using CCTV on the platforms. And to complicate this further, my fellow friends, we are always able to complicate something further. This was not centralised to Metrol. Station staff and signallers needed to call in the location of the train and observe it physically. The safety report highlights this as a contributing factor to the decision-making over the next 10 minutes. Nobody quite knew where the train was or how fast it was going. Speaking of how fast the train is going, let's take a look at the line ahead. Our runaway has recently departed Broadmeadows, and ahead of it is a big hill. At its peak, the Glenroy Bank is a stretch of about 2.8 kilometres of 1 in 50 incline. With gravity assisting, 5264 has nothing to stop it, other than a small hill towards Essendon, and then it's all the way downhill to Spencer Street. As our train races through the night, we should ask ourselves, what systems would normally stop a train? Let's talk about failsafes in engineering. It's important we have a shared understanding to frame this discussion. A failsafe in engineering is a system that is designed in a way that, when failing, defaults to a safe outcome. That's similar to, but different to, a fail secure or fail open mechanism. Most of you, I hope, are familiar with MFA. If a code can't be delivered, the security of that identity remains closed. Let's see how this design thinking applies to the brakes on our ComEng EMU. How might that stop a train? This train is fitted with a hierarchical system which provides a primary brake mode with additional backups. The brakes are applied using a handle applied using the driver's left hand. Ultimately, during a braking failure, each subsequent system cuts in at a similar braking effort as indicated by the position of that handle. Ultimately, during a braking failure, if each system fails, then the whole system goes in to apply the emergency brake. This is a really important design decision. It's deemed that a train not moving is safer than a train that is moving that didn't want to be. In this particular train, the primary rheostatic brakes had been noted as being faulty by the previous driver, and that meant that we were using slightly less efficient EP braking. EP brakes convert electrical signals from the brake handle into air pressure in the brakes. And now the ATSB report specifically excludes this failure as a contributing factor to the incident, and it actually has further extensive coverage into the function and operating procedure of the brakes in question. Interestingly, the investigation noticed that several drivers had different and inconsistent practices when applying the brakes and cutting out the cab, and that's what we encountered when changing ends back at Broady. The report also notes that it was common practice for drivers not to apply the park brakes, and that was the case for 5264. Thanks to POTS data, we do know that the brakes were at least initially applied correctly, following procedure. However, we have a runaway on our hands, and that tells us conclusively that a failure did occur. Now remember, this ComEng EMU is designed to be controlled from either of its two driving cabins, but importantly, never both. And as such, these brakes must be consciously cut in at the driving cab, and it is a valid configuration to have no active cab. And so since our driver never made it to 394M, our train is racing through the night with no active brakes and no active headlights either. Now another failsafe, perhaps better known to folks here, is the driver's pilot valve, occasionally known as the dead man's handle. This is a brake lever that must be actively held into an open position. It defaults to a closed position via pressure in the brake system. And yet once more, this failsafe is only enabled in an active cab, and it was not active on our runaway train. Our third and final failsafe is the automatic mechanical trip arms, creatively named train stops. These are fitted to all ComEng trains, and it's actually a delightfully simple system by design. When a signal is set to stop, a small arm is raised next to the track. The train stop is a lever lowered beside the train. If it passes a signal at stop, it triggers the brakes. But our failsafe was not to be in this scenario because, can we say it all together? Not enabled unless it's an active cab. That's our trend here. All of our failsafes were dependent on the train having an active cab. When it comes to changing ends, the report highlights that the only systems that can prevent a runaway is the combination of both the adherence to procedure and then applying the park brake. At this point, our train had been proceeding through all green signals since the Broadmeadows signaller had set the routes before departure. So it's at this point that our train will proceed at full momentum through its first stop signal at Glenroy. In railway terms, up is the direction of travel towards a major location. At Glenroy, the station is then followed closely by our first level crossing in that up direction. In this configuration, trains that are scheduled to stop at Glenroy will trigger the level crossing slightly later. This helps to optimise for road traffic flow and reduce dwell times. With Gravity as our train driver, 5264 did not slow on approach to Glenroy and proceeded through the level crossing at speed. Now thankfully, the automatic gates had lowered automatically, but with little or no safety margin. Other level crossings along our route were operated similarly, or manually by Metrol officers who had the forethought to close them ahead of time. You might have realised by now, nobody quite knew what to do with the runaway train. I suspect everyone had a moment of indecision and decision paralysis, since it was unclear if passengers had boarded the train back at Broady. I mean, it's certainly possible they would have. That was the driver's intent. It is 2003. Mobile phones are not pervasive. We're not expecting any calls for assistance. We're definitely not expecting any TikToks. The lines ahead of 5264 presented relatively limited options to Metrol. Okay, you could try and stop the train with Gravity. To do that, you'd have to route the train first through Flinders Street Station and then up hills to the east of Melbourne. Not only would you have to navigate the tight curves of the viaduct, but you'd then have to traverse busy passenger platforms in the heart of the city. And these tracks are designed for very low speeds. They'd also have to hand over routing control to Connex for several of these options. Connex is another rail operator in Melbourne. You might remember I said it was the privatisation era. You also couldn't physically route the train through the city loop, since the signalling here has a blocking mechanism that prevents trains from entering the tunnel when it's already occupied. And you might suggest, yes, there are sidings and yards around North Melbourne. However, these have similar tight curves and flyovers, and that was equally likely to cause a derailment with possible passengers on board. Eventually, they made the only decision they could: route it towards the country platforms at Spencer Street. And so, Metrol called Spencer Street's number 1 box with less than 7 minutes on the clock. That conversation is thankfully transcribed for us. Yeah? Yeah, who's this? Yeah? Yeah, mate, we got a situation here. We got the runaway train, the train from Broady. Yeah? Well, it's already at Glenbervie going towards Essendon. Just wondering, the suggestion we're going to bring it towards you. You're going to bring it towards me. Yep, number 1 box. Oh, really? Where am I going to put it? Oh, anywhere that's safe for a train to stop. If that one will come towards you, Spencer Street, I haven't got any platform to put it in. Oh, you haven't got a platform to put it in? Nope. Well, the only place I'll have is platform 1 when the Adelaide goes, and then it'll run down and hit the bottom anyway. Yeah, that's the thing. Well, then it'll run out of wire, and then of course nothing moves. And that's what they want to do. That's right. Righto. Okay, no worries. No worries, see ya. Hey, listen. Needless to say, this conversation did not really convey the seriousness of what was happening. I get the feeling that number 1 box just assumed they'd use platform 1 when the Adelaide goes in 10 minutes. I guess we'll see how that goes, won't we? While all of this had been going on, Metrol had also arranged to isolate power to the line. The report doesn't specify why they thought this would stop the train, but staff did not have the benefit of hindsight that we have, and so we can't throw too many stones. Perhaps they did genuinely think the train was under power. This decision, however, did affect POTS. As we can see from this table of data, once the power was cut, our runaway train was recorded as 0000. This is the manufacturer default after a power outage. And so these measurements are therefore assumed but congruent with the passage of our EMU. Ahead of our runaway, the previous Broadmeadows service to Flinders Street had just left Kensington, operating as train 5262. A decision was made to get it out of the way via the main suburban lines at North Melbourne, and thus changing its existing route. Once a route is cancelled, new points cannot be set for 90 seconds. This timeout prevents the points from changing while the train is progressing through the signal. The driver of 5262 wasn't expecting this delay, and he was about to exit the cab and call for information using the phone box at the signals. The report notes that he was surprised that his radio actually worked when he was informed by Metrol of the runaway behind him. Approximately 2 kilometres behind him, the Kensington signaller observed that 5264 was, and I quote, going like a tyrant. And sure enough, 5262's driver saw the runaway approaching behind him. With some understandable enthusiasm, 5262 sped through the now green signal and onto the main suburban line at 62 kilometres per hour, far in excess of the 40 kilometre limit. The interlocking of these points would not revert until 5262 had vacated the completed circuit. For a fleeting second, and with static on 5262's radio, the Metrol signallers displayed the trains had actually collided. Data later shows us that it was a dead heat, and that the points changed within a second of 5264 speeding through. With hindsight, we can see that the routing decision did contribute to the near miss. However, the ATSB does not lay fault with this decision making. It describes the runaway as uncontrolled and uncontrollable. Furthermore, it emphasises that the only available options to Metrol officers were contingency measures, either rerouting trains and then warning relevant personnel of the anticipated movement. In fact, the report further highlights that the emergency response plan did not deal with runaway trains. And there was also very little training in that response plan. Nobody had grasped the actual speed of the runaway, and they made the best decision they could with the available information they had. Wait, distracted by this north miss at North Melbourne, we still haven't told Spencer Street. Unfortunately, we don't have a complete transcript of the multiple conversations that happened, but some choice quotes seem to suggest the urgency was somewhat well understood. 5264 was routed towards Spencer Street via the East Country line, and the report notes that signallers protested they did not have a clear road. You'll remember Spencer Street country platforms had locomotives and trailer cars on all 7 platforms. Signallers made a last-ditch effort to take the route off the Bacchus Marsh train on platform 2, but the points were already on that timeout I mentioned earlier. 5264 sped through the last available points and claimed the route set for 8141. As 5264 sped towards the platform, there was nothing more that could be done. And at 9:33, train 5264 crashed into 8141 at 75 kilometres per hour. The driver of 8141 had no advance warning. It was only in the final seconds that he saw a train hurtling towards him that he shouted and vacated the cab. 8 passengers reported minor injuries. 4 required brief hospitalisation. All injured passengers were discharged from hospital the following day. There was no loss of life. Shortly after, a police helicopter flew over the route of the runaway with thermal imaging cameras to determine if there was any unknown injuries, but no further incident was reported. Subsequent train drivers were instructed to proceed with caution, and Broadmeadows services resumed shortly after. Approximately 36 hours after this incident, the rail safety regulator published a bulletin with some clear and unambiguous guidance. All operators of ComEngine Hitachi rolling stock are to amend work procedures and instruct train drivers to use the park brake when changing ends of trains, for any reason. As technologists, it's incumbent upon us to consider the ramifications of design decisions, not just for the affirmative, happy path of a business case, but also the consequences of failures along the way. The more complex a system becomes with subsystems, services, dependencies, the more difficult it is to evaluate all those possible outcomes. This is especially true when we reach outside of our internal delivery capabilities and we work with third-party platforms, LLMs. Build with intentionality for both the success case and your failure scenario. Now, as a consultant and fractional CTO, I am frequently thrown into operating environments where software practitioners have little or no observability into the systems that they're operating. Just a few weeks ago, I supported an incident where engineers had mistakenly failed open to meet a business case. Specifically, they'd failed to implement null checks for an edge case in an authentication handler. You can imagine that went particularly well. This appeared to work on launch, but it started causing infrequent but catastrophic failure in several scenarios. This cascaded over several weeks, and before they could finally instrument the appropriate telemetry and understand the complexity of the stack. Now, in the case of our runaway, Metrol signallers had no real-time insights into the system they were operating. The closest they had was some visibility from the POTS transponders at specific signals. How much insight do you have into the platforms that you're operating today? Are you using an observability or an APM tool to inspect and improve your production environment? Have you signed up for Night Watch waitlist? It's not always possible to know all the failure modes either. As engineers, we're all frequently building with and building APIs operated by colleagues, partners, service providers. In these situations, some failure modes might be documented and communicated to us, but the operating parameters are almost always kept confidential, and every edge case can't be enumerated. In these environments, it's paramount that as software engineering professionals, we carefully consider the outcomes of the business case and then architect our complex systems with fail-safes in mind. ideally without the corresponding safety fails to match. Now, there's lots we could say about incident management. That needs a whole talk to itself. But we can learn a few things from this incident as well. When you're managing an incident, pause and carefully understand the command and control structures that influence clear communication in the moment. Metrol officers were operating in a complex organisation with many different communication technologies, standards and conventions. As we saw, clearer communication could have aided signallers with better context and clarity, potentially allowing for more optimal decisions in the moment. The report did note that there were hypothetically more optimal ways to crash this particular train. What a weird statement. And while we're thinking about communication, it would be remiss of me to skip to not mention documentation. As demonstrated by this crash, inconsistent and disparate documentation can lead to inconsistent behaviours by your colleagues, partners and customers. This isn't just update your docs. It's a call to action to carefully consider the technical communication requirements that will set your users, internal or external, up for the success of your shared vision. The consequences of delaying or deferring this effort can be catastrophic. And so I leave you today with some social permission. I want you to embrace your inner geek and go read a safety investigation report. Regulators around the world embrace their curiosity, and these blameless retrospectives make for fascinating observations into behaviour, communication, and technical design practices. Even 20 years on, we can still learn from these recommendations. Remember, always be observing and questioning your patterns and practices in an effort to improve safety within the systems that you build. And always apply your park brakes.
I do enjoy story time with Uncle Jack. Jack, come and stand on the little orange cross.
Hot seat.
Hot seat. Would meaningful observability have changed the outcome, do you think?
Yes, it was very clear from the outset of the train movement that it was minutes upon minutes before anybody knew there was an issue.
Yep.
And so by having observability in place and understanding that there was a deviation from the schedule, there would have been early warning to make potentially better decisions in the moment. Would it have changed the outcome? No one will ever know. But it gives a tool to the people in the moment to act with more detailed and contextual information.
Mm-hmm. Can't believe I'm going to ask this. Did they need to crash the train for your talk, or could there have been some other way of doing this?
So the ATSB investigation looks at decision-making and information available, and there were, in theory, some different sightings for freight lines and things that may have been available. So all of the options available would have resulted in a likely crash. Mm-hmm. They could have potentially changed routing to crash into a train or a trailer car that had no passengers on board, for example. Mm-hmm. It was purely, thankfully, timing that most of the passengers were not sort of on the train and off at motion. It was, pretty tight.
Very good. Thanks, Jack. Nice to have you on the stage this year.
It's good to be here. Thank you, everyone.